Okay, thanks to Dalton, we have the understanding of atoms, how atoms make up our elements, atoms make up our compounds, and we're ready to kind of dive into the atom. And we're going to start looking at the atomic structure beyond just the atom itself, what makes up the atom inside of the atom. And we're going to start by looking at the discovery of an electron with this lecture here. Now we know almost everybody comes into chemistry understanding that atoms have electrons, protons, and neutrons in them. What we really want to look at here is not, yeah, they have those in them, but we want to look at the discovery process. We want to look at the experimentation that led to these discoveries. So it's going to be important that you look at the experiments, you understand how those experiments led us to the understanding that these electrons, to start with, existed. Okay, so this is a schematic, and in this schematic it is of a cathode ray tube, and we're going to go through and look at the components of this cathode ray tube bit by bit. Okay, and this is the beginning of the idea of our electron. So number one, what we have is an evacuated tube. We've taken all the air out of this glass tube, and the second thing that we have got is we hooked it up to a high voltage. Now this is a strong battery, so we have a terminal hooked up to this. Now all of this is, we know now batteries have the flow of electrons, but this was not really known at the time how these all work, but we knew we had this high voltage that we could hook up, this battery could hook up to this. Now we see here that it is hooked up to we had the anode and the cathode. So the battery here has our cathode. What we can't see very easily here is that the anode has a little hole in it. Okay, so let's see, right here, right in the middle, there is a little hole. They hooked up that electric field to it, and what they found was a beam of particles, and they called them cathode rays, were passing through that little hole and striking this base of this cathode ray. So they're striking back here, and they're striking at this point right here. Okay, so they knew that it lit up, so they had put some kind of coating on this screen that would glow brightly if it got struck by these cathode rays. And then they started performing experiments on this. Okay, what they did is they started applying electrical fields to this, and they moved the beam around, and they added magnetic fields to this, and they moved that beam around. And so they were able to manipulate it by both electrical fields as well as magnetic fields. So they knew that whatever was coming through here and striking the back, they could deflect it up, they could deflect it down, they could deflect that beam by adding electrical fields. And so they knew that it was manipulated by those electrical fields, and by adding magnetic fields they could manipulate it as well. Okay, so let me go back to this and just mention one last thing here. The electrical plates we're not seeing put in here, but what we found was that when these beams moved, okay, when they deflected it, actually I had the plates right here. Let me do a little erasing so that we can see nicely what's going on in this little zone right here, okay? The electrical plates that they put in, when they turned them on, okay, so they're turning these plates on, and it's an extra electrical field turning on. They found that those beams deflected away from the negative and towards the positive and struck the plate right there. Okay, that's going to be an important thing, is they moved away from the negative, they moved towards the positive, and they hit the screen down here at the bottom. So what did this experiment show us? Okay, the first thing it showed us is there's some sort of particles. They knew that these were tinier than the atom, and so there was something coming from that battery, passing through those electrodes, hitting the screen, so there was something that exists there. The second thing that they knew is that these things had to be negatively charged, because at this point they already knew opposites attract. Yes, opposites attract, like repel. So it is moving away from the negative towards the positive. This is going to tell us that these particles had to be negatively charged. So there's something there. This something is negatively charged. Okay? Now, Thomson did some work with his cathode ray tube, and he came up with this notion that he could come up with a charge to mass ratio. That's what it says right there, the charge to mass ratio of these particles. Now the charge is measured in coulombs. That's what the C stands for right there, coulombs. And this tells us that and it's negative, it's a negative charge, a negative 1.76 times 10 to the 8th coulombs on every gram of these particles. He couldn't figure out how much the particles weighed. He didn't know how much charge was on each particle, but he knew that if you had a whole gram of them, it would carry 1.76 times 10 to the 8th coulombs. And it was also noted with his experiments that whatever this particle was, they knew what the smallest atom was, it was hydrogen. Whatever this particle was, it was about 2,000 times lighter than the lightest atom, which was, of course, hydrogen. So these are some of the things as we start developing the concept of the electron. Well, we still don't know how much an electron weighs. We just know it's way less than a hydrogen atom, and we know how much charge a gram of them would contain. Okay, so what happened next? The next thing that happened was the Millikan oil drop experiment. Now the Millikan oil drop experiment, we've got a schematic here, and I'm going to want you to read about this experiment. It's on 2 pages, 50 and 51 in your book. In this experiment, what you're going to see is that they were to take a substance, which was just oil, and they could spray it into this chamber with little drops, and they would fall, okay, naturally fall. There's a little tiny hole, and some of them could fall through this hole and travel down there. And they could look at the drops of oil pass through using this viewing microscope. And they would be looking for those little drops of oil. So I want you to read about this experiment and see how in the world this helped us go beyond the charge to mass ratio and actually determine the charge of an individual electron. So that's what you're trying to determine by reading this. If you have any trouble with that, make sure you contact me, come by and talk to me and see how does the wording in these pages help me understand that the charge of an electron could be discovered to carry this charge. Now this is the charge of each individual electron. It is a very, very tiny number. Now, if you know from the previous slide the charge to mass ratio, and you know the charge of each individual electron, then what you can determine is determine the actual mass of an electron. And it's just a little mathematical manipulation with this number here, which I'm showing you here. The number on the previous slide, which was the charge to mass ratio, comes up with this being the mass of one little bitty electron. Now this is a tiny, tiny number. I do not want you to memorize these numbers. They're not important for you to memorize. However, I want you to know the experiment and the concept, and I want you to understand that this is tiny. This is a very, very, very small mass that these electrons have. So, the cathode ray tube experiment and this oil drop experiment led us to 2 things. Number 1, the knowledge that electrons existed. Number 2, how tiny they were compared to the atom. And they actually came up with that tiny value of charge and mass for each one of those electrons. Okay, so let's end with this question, which was the next thing that they had to consider. Electrons exist. Electrons are negatively charged. Electrons are contained within that atom. Okay, now if atoms themselves don't have a charge, and that is a fact, they have no charge themselves, what has to be the logical conclusion of that information? I want you to think about that and choose one of those answers. Well, if you decided that there must be something positive in there as well, because negatives and positives together gives us something neutral, then you would be using your nice logical scientific mind to figure out what the next discovery is. So we'll stop with this video and we'll resume the next one thinking about those positives.